Introduction to Quadratic Equations. Well, what do we mean by the word quadratic? Let's explore this by analyzing the root word quad. What does quad mean? Well, one word with quad in it is the word quadruple, which means to multiply by 4. If you double something, you multiply it by 2, triple, multiply by 3, and quadruple, multiply by 4. Another word with quad in it is quadruplets. If you have twins, you have 2 babies at one time, triplets, 3 babies, and quadruplets, 4 babies at one time. And finally, a quadrilateral is a shape with 4 sides. So obviously, quad means... No, it does not mean 4. Quad fundamentally means square, which happens to have 4 sides, and quad is often used in words that refer to the idea of 4, but fundamentally quad means square. And that's important because quadratic equations have nothing to do with the number 4, but everything to do with squares. So, what are quadratic equations? Quadratic equations are equations that involve a second-degree polynomial, or in other words, equations where the largest exponent is 2. Let's take a look at one. X squared plus 5 equals 7. Is this a quadratic equation? Well, the largest exponent is 2. And notice how I said that. X raised to the second power is always called x squared. We refer to it by saying x squared. Why? Because that's how you find the dimensions of a square. And that's where the word quadratic comes from. It comes from equations where the variable is squared. Let's look at a few other quadratic equations. Here's x squared equals 36. Again, largest exponent is 2. 2x squared plus 3x minus 4 equals 0. Largest exponent, 2. 6x squared minus 15x plus 9 equals negative 12. Largest exponent, 2. And then 4x minus 2 equals 3x squared plus 9 is a quadratic equation. Why? Because the largest exponent is a 2. So the variable is being what? Squared. Now, let's take a look at what the standard form of a quadratic equation is. Ax squared plus bx plus c equals 0, where a represents the coefficient of x squared, b represents the coefficient of x, and c represents a constant, or just a number. Let's take a look at these 4 quadratic equations. Take a moment to identify the values of a, b, and c. Pause the video and try it on your own. Alright, let's see if you did a great job. So the first thing I'm going to do is color code this so you can easily see the answers. So in this first one, the value of a is 2. We know this because it's the coefficient of x squared. The coefficient of x is 3, so that makes our b equal to 3. And then our constant is 4, so c equals 4. In the second one, the coefficient of x squared is negative 6. The coefficient of x is 4, and the constant is negative 9. In this third one, the coefficient of x squared is 10, the coefficient of x is negative 14, and the constant is 7. And in this fourth one, the coefficient of x squared is negative 8, the coefficient of x is negative 5, and the constant is negative 13. Now, this may seem simplistic, but it becomes very important later on. Let's try a few more. Here's 4 more. I'm going to walk you through the first one because these equations are somewhat different than the ones we just looked at. Let's take a look at the first equation, 8x squared plus 5 equals 0. Notice this equation only has 2 terms on the left-hand side, but a quadratic equation is supposed to have 3. That's how we identify a, b, and c. So how are we going to do this? Well, we need to represent the third term somehow, or in this case, it's not the third term, the middle term, the missing term. So what would the coefficient of x be if it weren't written there? If you said 0, you'd be correct. So we could rewrite this as 8x squared plus 0x plus 5. Anything times 0 is 0, and we don't have to write that. But when we're trying to identify our a, b, and c, we should write it like this so it's easier to see. So it's easy to see now that the coefficient of x squared is 8, the coefficient of x is 0, and our constant is 5. Using this as a model, try the next three on your own. Pause the video now. Alright, let's see how you did. So in this equation, there's only one term. So what's the value of b and c? We could rewrite this as negative 3x squared plus 0x plus 0. When we do this, it's easy to see that the coefficient of x squared is negative 3, the coefficient of x is 0, and our constant is 0. Now we don't have to write this, but when we're identifying a, b, and c, which as I told you becomes very important later on, it's important to understand that this is another way of representing negative 3x squared. When we write it in standard form, we can easily identify a, b, and c. Let's take a look at the next one, 5x plus 7. Now you might have been tempted to write 0x squared as your first term, but you should have realized that this has no variable squared. Quadratic equations always have a variable squared. And you should recognize this as a kind of equation that you've seen before. This is a linear equation. Therefore, it's not quadratic. It's not in the standard form of a quadratic equation. So there's nothing to do. Now, finally, in this fourth one, you might have been tempted to say that 7 is the value of A, 5 is the value of B, and 20 is the value of C. But if you notice, this equation is not equal to 0, it's equal to 6. Now, the standard form of a quadratic equation requires that it be equal to 0. Therefore, before we start identifying our A, B, and C, we must first make the equation equal to 0. So we can set this equal to 0 by subtracting 6 from both sides. 6 minus 6 is 0, and 20 minus 6 is 14. And now we can easily identify A, B, and C. The coefficient of x squared is 7, the coefficient of x is 5, and our constant is 14.